Welcome to Unit 4, Lesson 1. This is the second part of this lesson. We're still going to be talking about how we shift numbers, which means to move numbers to the left when multiplying by powers of 10. Powers of 10 are numbers that have ones with zeros following them, such as these three numbers. 100, 1,000, and 10,000 are all powers of 10. We learned in the last lesson that depending upon which power of 10 you're multiplying by, all we need to do this problem is know that we are really just multiplying our two whole numbers, which is 3 times 1, which is 3, and then adding the number of zeros. So 3 times 100 is 300. So this was taught in the last lesson, and today we're going to be doing that same thing, except just a tad bit different. And the first thing I want you to do is to take a look at this chart and see if you can find the patterns that exist in this chart and what this chart is trying to represent to you. You may pause this video now if you need to. Take some time to figure that out. Okay, so this looks kind of like a multiplication chart that you're familiar with when learning your math facts. On the top rows, we have, instead of our math facts 1 through 10, we are starting with 3, and then we're using that 3 to create multiples of 10. So we're going from 3, adding the 0 to make 30, adding 2 zeros to make 303 to make 1,000. And on the left-hand column, as you go down, we're doing the same thing, but we're starting with the number 2, and then to make a multiple of 10, we'll add a 0 to that to make 20, then 200, then 2,000. But we're using this very similarly to a multiplication chart where they connected these two numbers, 3 times 2, showed that here and gave you the answer 6. Did the same thing with 2 and 30. So they're showing the multiplication, 2 times 30 here. They're breaking down the problem for you and showing you how you would do this mentally. You would break this problem down into 2 times 3 and then multiply that answer times 10, or just add a 0 to that answer. 2 times 3 is 6. The answer is 60 because you would then take your 6 and multiply it by 10. Or, having known the pattern and the tricks, that you would just add a 0 to the 6. Do the same thing with 2 and 300 is 2 times 300, which is the same thing as multiplying your whole numbers, 2 times 3, and then adding a couple of zeros. 2 times 3 is 6, and then add the 2 zeros. They're breaking it down into one extra step. They're doing 2 times 3 times 100, and then they're multiplying 2 times 3 like it's a multiple operation problem. In multiple operations problems, when it's all multiplication, it doesn't matter what you do first, but I would say box the first thing you're going to do, and then solve it, and then rewrite everything else, and then box, and then solve, and you would end up with 600. You're probably already thinking that you could skip this step here, breaking it into 2 different multiplication problems, but it is a step that you're going to need to be aware of, and eventually you will just be skipping that step and going right to the answer. So on page 118 at the bottom of that page, there are some problems for you to practice. And you can do these problems any way that you see fit, any way that's easiest for you. And typically I would try to encourage you to do this mentally and to do 6 times 3 first, and then to simply add as many zeros as you need to the answer. So I will do just one for you, one of the more difficult ones. We'll do 42. 42 would be 6 times 3, which is 18. And then there are 1, 2, 3 zeros. And you'll see that I'm counting all zeros in both numbers. That is necessary. It is allowed to kind of exclude these zeros or cross them off or not use them. Multiply your whole numbers, get 18, and then replace or return these 3 zeros to your product. Product, remember, is another word for answer to a multiplication problem only. Go ahead and complete problems 40 through 44 on your own, and then I'm going to move on to the next page. In this next page, we're actually shifting gears a bit. We're going to show you how to simplify a multiplication problem such as this one, where you have repeated multiplication. Anytime you're repeating the exact same multiplication, there's a way to simplify that instead of showing it like this, 10 times 10 times 10. That we have a way of simplifying it into one simple number with what's called an exponent. So an exponent, which is up here in the vocabulary, an exponent is a number that we use, that we put on the top right-hand corner of a number, such as this 3 here, and it tells us how many times to repeat the base number. And so if you look over here, we have all of our vocabulary actually illustrated for you. So again, our exponent is this tiny number up here. It goes in the top right-hand corner of the base number, which is the number that's going to be repeated. So we took a multiplication problem, 10 times 10 times 10. And if you know that 10 times 10 times 10 is the same as 1 times 1 times 1, which is 1, with 1, 2, 3 zeros after it. So 1, 2, 3. So we know that 1,000 equals 10 times 10 times 10. But another way to show that multiplication problem so that we don't have to write it out like this is to take your base number that's being repeated, which is the 10. Count how many times it's being repeated, 1, 2, 3 times, and show that with an exponent. And whenever somebody sees this, they know that they are to take their base number and repeat it 3 times, and that we always use multiplication signs for exponents. So exponents is a way to show multiplication in another way, but it only works if it's repeated multiplication. And you have to be extremely careful and remember this, because a lot of times you will forget that you have to repeat the base number 3 times and multiply it to itself 3 times. When you do that, you get the answer 1,000, which is the correct answer. But a lot of people will instead see this as 10 times 3. Well, what is 10 times 3? That's right, it's 30. And 30 is not the same as 1,000. So if you do this incorrectly, you will not get the same or the correct answer. You have to remember that exponents is repeated multiplication. What are exponents? Repeated multiplication. What are we going to repeat? The base number. How do we show how many times we repeat the base number? With an exponent. This can be done with any number. I could ask you to write 2 times 2 times 2 times 2 as an exponent, or write this problem in a simpler way. And you would say it's the same thing as 2 to the 1, 2, 3, 4th power. 2 to the 4th power. It's kind of like a code in math. It's a code. And when you see this, you know what the code means. The code means repeat the base number this many times. And of course, it means to multiply when repeating that base number. There is no other sign you will ever use. Exponents always go with multiplication. We have a couple of special names for 2 of our exponents. So I'm just going to show you those very quickly before we move on with this lesson. We have an exponent of 2 and an exponent of 3 where we have special names. Normally we'll say that this problem is 10 to the 2nd power, we use the word power. So we'll say 10 to the second power. And following that rule, you would say then, this is 10 to the third power. And there's nothing wrong with using 10 to the second power or 10 to the third power, or even reversing that a bit where they say to the power of. They say 10 to the power of 2, 10 to the power of 3. Either of those is correct. But for these two exponents, 2 and 3, we have special names for them. And for anything that's to the power of 2, that special name is squared. And you've heard that name before because you've used it when finding area for just about anything. We always use squared when we're talking about area. And for the 3, we have a special word for it as well. It's called cubed. And you may not be familiar with that yet, but that's what we will be using when we find volume. We're looking to see how much space fits inside of a box. We will use cubed. So that's a name. That's what we will be calling powers of 2 and 3 from now on in the classroom. We're going to say squared and cubed. Anything else, you'll just say to the power of whatever that number is. So the power of 5, power of 6, power of 10, power of 100, whatever it is. And now we're going to go on to number 45. Number 45, we're asked on 45 through 48 to rewrite these, write the expression as repeated multiplication, and then solve. So I'm going to show you how to do this with number 5. Of course, I'm going to take the easy one this time. And to show repeated multiplication, we'd say, okay, our base number is 10. We're going to repeat that number how many times? 2 times, because the exponent is 2. So 10 times 10, and we're going to solve, is 100. Or 10 times 10 is 1 times 1 with 2 zeros. I'd like you to complete 46 through 48 on your own. And then 49 through 54 is asking you to rewrite these expressions using exponents. And so I'm going to do number 49 for you. Number 49 has some repeated multiplication, 10 twice. And so we can't do anything with the 5 because it's not repeating. So we could say that it's the same thing as 5 times 10. And how many times do we need to repeat that 10? Twice, because there are 2 of them. So it's the same as 5 times 10 to the second power. And anybody who saw this would know that that is code for this problem. They would be able to rewrite it. I'd like you to do 50 through 54 on your own now, please. And then come back to the video. If you're ready to move on to the last page, I will show you how to do this page. The first part is asking you to look for patterns, and I'd like you to do that as well. And it's showing you that 3 times 10 to the power of 1 is the same as 3 times 10. Using the power of 1 isn't really necessary then, because taking the power of 1 off doesn't change that problem at all. So using the power of 1 is redundant. It's not helpful code because it doesn't mean anything. But 10 times 3 is 30, so that solves that one. Here we have 3 to the times 10 to the power of 2, which is the same as 3 times 10 times 10, which one way that I look at that is I look at my whole numbers and I multiply them first. 3 times 1 times 1. 3 times 1 is 3 times 1 is 3, and I would put that, and then I would add the zeros that I need to add, which is 1 for each of the 10s. Of course, there's always more than one way to solve any problem, and if you knew that 10 to the second power really means 100, or 10 times 10, which is 100, you might also recognize some other patterns there that could help you solve this a little bit easier. I added not 1 0, but 2 zeros, and I added 2 zeros because there are 2 zeros in both of these numbers combined, as well as if I'd known that 10 to the second power was 100, there's 2 zeros there as well. Well, there's something else that tells you to add 2 zeros, and I'm wondering if you can find that as well. Go ahead and solve the next 2 in this problem. And 55, if you saw any patterns that were evident to you, go ahead and write them in. And then 56 through 64 is much of the same. You're going to be solving the same kinds of problems. And here it just says find the value. And here it says complete the pattern. Well, essentially you'll be finding the answers, and then you will see the patterns develop as you find the answers. Go ahead and complete all of page 120.